Hi, I'm gonna present to you today the de-extinction of the thylacine. There was an article written in Scientific American in August by Kate Evans about the efforts of a company named Colossal Biosciences to de-extinct the thylacine. In this article, I'm briefly going to go over why de-extinction is being proposed, how this procedure would be done, and some reasons why not to perform the procedure on the thylacine. So what is the thylacine? The thylacine is a marsupial that used to live in Australia and Tasmania. Its nickname is the Tasmanian tiger because of the stripes on its back, and another nickname it has is the Tasmanian wolf because of its dog-like appearance. It's about the size of a dog. It went extinct in 1936 after a long decline. It was hunted into extinction by European colonists after the government in Tasmania started rewarding them for the hides of the thylacine. The government wrongly believed that the thylacine was responsible for killing the chickens and sheep, so they wanted them hunted. So why de-extinct them? Because their extinction to begin with was caused by humans, and the ecosystem in Tasmania hasn't recovered since their removal from that habitat. The herbivores have overpopulated and are now threatening the forests there. And then also another reason to de-extinct them would be the new reproductive technologies that could be developed that would aid humans and aid in conservation. So the de-extinction procedure would be done first by fully sequencing the genetic code of the thylacine. Right now, we have about 96% of the genome sequenced. After sequencing the full genome, the scientists at Colossal Biosciences would use CRISPR gene editing. CRISPR stands for clustered regularly interspaced short palindromic repeats. It's basically a way of copying and pasting genetic code into different organisms. So the way this would be done with the thylacine is they would take its closest extant relative, the currently living fat-tailed dunnart, which is basically a mouse, and they would take a stem cell from that dunnart and turn it into a embryo with a genetic code that's closer to the thylacines. And over many generations, it would become more like the thylacine. But in order to do this, the technologies of artificial wombs, artificial pouches, and artificial marsupial milk would need to be developed. There are a few reasons not to do this. One would be the suffering of the dunnart and the thylacine hybrids on the path to de-extinction. Two would be that it's just not possible. There's only ever been one de-extinction. It was the Pyrenean ibex back in 2003, and that had only been extinct for 3 years before 1 out of 100 embryos was viable and was actually born for all of 7 minutes before its lung collapsed and it died. So it's not for sure, tested procedure. And for this reason, many say that there are better uses for the funding for conservation, and that because the de-extinction hasn't been proven out, that it should go to other areas of Tasmanian conservation. And then there's another camp that thinks that what's done is done, and there's no reason to bring the thylacine out of extinction because it's extinct and we shouldn't be playing God. So in conclusion, in 1936, the thylacine went extinct. And this year, Colossal Biosciences began a project to de-extinct the thylacine. Who knows how long this will take, if it can even be done. Colossal has said in the next 2 decades, but we'll see. That's my presentation. Hope you liked it.